Good morning. So as I said or alluded to in the last video, it would be really cool to have an idea how to get our robot to automatically adjust and steer toward a brightest light. And to do that, we would need essentially two photoresistors, two of these guys right here, right? These things, and two regular 10K resistors, the brown, black, orange ones that like we have over here. And so let's take a look at the chip. Let's find a couple places to hook this stuff up. Go back to our handy diagram here. Currently we're using, what are we using? We're using A0 for our input, analog 0 for our input of the first photoresistor. And we are using 0, 1, 2, and 3 to control the motor's directions, both the left motor and the right motor. And we chose 4 for the pulse width of the left side. So I'm thinking we might as well use, you can use another if you wish, but I'm going to go ahead and use 5 for the pulse width of the right side. And I think I'm going to use, just because I want to keep those two photoresistors separate so we can actually watch it happen on this breadboard, I'm going to go all the way up here to A9, which is pin 23, which is the fourth pin from the back. I'm going to use that one to hook up my other photoresistor. Okay, let me just do it. What the heck? We'll do it quick. One thing I did realize this last video, I did something that's not so good. So I'm going to explain what I did and tell you not to do it, and I won't do it again. You recall when I was building this circuit quickly before, I hooked the resistor up before I hooked up the photoresistor. The resistor is hooked to the power. The photoresistor is hooked to ground. I didn't unplug the cable. Okay, I don't have to unplug the cable. It's a good idea. But the other thing I can do to avoid those sort of snafus is there's a couple of, I'll reference a saying in chemistry, you're supposed to do what you oughta, add acid to water. And in this case, in dealing with digital, always sync first. Alright, I know it doesn't quite rhyme as nice, but we're going to go with it anyway. So, that being said, I'm going to hook my photoresistor, this guy, up to A3, which was the fourth pin back. And I am going to make sure that I sync it first. That way, there's no way that I can be putting a pulse of power into the pin. It is possible to damage these analog pins by putting in more than the 3.3 volts. So, and of course this is hooked up to 5. So it's possible we could damage the pin. You know, I'd have to hook it into analog first, because digitally I think it'll hold 5 volts. And secondly, 10K resistor kind of cuts a lot of the electron flow down. And now I'm going to hook up my my resistor. And actually I need to give myself a little more space. Okay, in this case I had a pre-cut resistor, so it's going to lay real low. Alright, which is the way we should be doing it in the end anyway, but we're just playing for right now. When we get into something serious like a robot, we'll work on that. And I'm going to move that a little bit further so you can see that a little better. Okay, I have taken and hooked up my photoresistor to ground to pin A9, and I have a resistor hooked to source, or to the power, hooked up to the same pin. So the electrons now have a choice. The other thing we have to do is we have to pull the enable pin. I should show you that real quick on the diagram. Let's jump back up here. Let's go to our pinout. Let's go to this one. No, let's go to this one. Okay. The enable pin on the right side of the chip is this one down here in the lowest corner. It is the one that we also hooked to source, and I just pulled it out. Okay, this pin right here. I just pulled the little red wire out. And I'm going to take just a jumper, just an ugly piece of wire here, and I'm going to put it here. So now it hooks up to that enable, and I'm going to put it into pin 5. Okay. So now we can control the enable of the motor hooked up to the right side by pulsing pin 5. Let's do this code real quick, because a lot of this is going to be just copying and pasting. Okay. First off, we now have a new in pin. We have, let's just call it, to make this quick, let's just call it in pin 2, and I hooked mine up to A9. Okay. We also have a new pulse width pin, and it's going to be the right one. And we have it hooked up to, I have mine hooked to pin 5, and I should change that to right. And I should make this the pin the second photoresistor is connected to. Let's see, what else? Okay, that all stays the same. That all stays a value. We're going to need another value. We're going to need another place to stuff our data. So let's call it value 2, because we want to collect data into this photoresistor. Oh, that looks good. All this remains the same. Ah, we've got another. Oh, I didn't comment that line. Dang it. We have another pulse width. Okay. I think all the rest of that looks good. I don't think we need to change any of that. Last time we took the clockwise one, this one, and we made a copy of it and called it clockwise PWM. Let's take the right clockwise. We'll make a copy of it, and we'll do the same thing, underscore PWM. And just like we did here, we had this analog right, which is the pulse the pin. We now have to do the same thing here. Oops. But we're not going to be doing the left. We're going to be doing the right. And we're going to be using value 2. Okay, because we're going to collect this one into value, this one into value 2. Probably should label those right and left. It would be more logical. But for the moment, we're going to go with this. And we're in a loop. This is fast and easy stuff. I tell you, when you start understanding it, you can write code really quick. We have it going into in pin 2, and we have value 2. Okay, from the second photoresistor, and I'll bet you can figure out what's going on. We now have the right. Okay, we're going to be collecting the data. We're going to be putting it into these two variables, and then we're going to call this routine and this routine. We're going to jump up, and boy, there's going to be a better way to do this, but we'll talk about that later, maybe in the next video. We're going to jump up here, and we're going to put the value into that pulse, and it's going to pulse it. And we're going to put that value into this one, and we're going to pulse it. Okay, I think this should basically work. And let's try it out. See if I get away without any errors this time. And it didn't start out because I'll show you what we're going to have to do to work this better. But let's, so if the light's on this side, this motor is getting really slow and moves over. This motor gets really, oh, you can't see this one. Let me drag this whole thing this way. There we go. Now you can see both motors. Okay? So you can see that the two motors change speed depending on which way the light is. Alright? So you can see if we had wheels hooked up to that, we could easily steer it toward the light. We can make it almost come to a complete stop. And it's proportional. Alright. Let me actually make it, we're going to pull this up again real quick. This is my little stop thing. And eventually we're going to build this into the code too, trust me. What I noted about this, and I think I'm going to explain it in the next video, if not the one right after that. Notice how we've done this, it calls the left and then the right, and it puts the value in there. Well, it's kind of dark, and if I recall, that darkness was something in the order of about, wasn't it like 800? And didn't it go from like 30 to 800, and 30 being bright, 800 being dark, and 800 is well over the 255. My guess is that because we're going from one then the other, we're kind of stalling out, and we might have to find a more efficient way to run this code. And I'll play with that, and we'll talk about it probably in 2 videos, because the next one we're going to do mapping, which is also going to make this a little bit easier, a little nicer. And well, I'll explain it in the next video. I will talk to you guys soon.